Alright, in this video we're going to be looking at solving some log equations where I can't get the same base. So if we look at this one here, we have e to the 2x minus 1 is equal to 5, and we don't have the same base. What we're going to recall here is e to the ln of x. Ln and e are inverses of each other, so they're going to undo each other, and we're just going to be left with x. Okay, so you can use any log you want, but we're going to use the natural log in most cases. 1, because it works nicely with e, and 2, because ln is one less letter than writing log. So we're lazy. So we're going to ln both sides. So anything you do to one side of the equation, you got to do to the other. Okay, and we'll note again that ln of e to the x is equal to x. So then we just are left with 2x minus 1 is equal to ln of 5. To finish solving this, we're going to add 1 to both sides. So there's adding 1 to both sides, and then we're going to divide by 2. And that's going to be equal to x. Now, depending on what we're doing, going to be doing, we may want to just leave it. This is the exact answer, but sometimes we might doing some sort of application, so it would make more sense to have a decimal approximation. So we're going to work through a couple more examples. These are kind of similar to what we had going on in class. So let's say we have negative 4 times 2 to the 1 minus x plus 3 equals negative negative 84. Okay. So kind of the first rule for solving these exponential equations is we'd like to isolate the exponential. So what we'd like to do is we'd like to divide both sides by negative 4. So we're going to divide both sides by negative 4. And we have 2 to the 1 minus x plus 3 equals 21. Next, we'll subtract 3 from both sides. 2 to the 1 minus x is equal to 18. Because we do not have the same base, we're going to go ahead and take the natural log of both sides. And this time, the ln doesn't cancel out with the 2 because they're not the same base. So you have 1 minus x. And we're going to mention the power rule. So ln of b to the x is x times ln of b. Bring down that exponent. So 1 minus x times ln of 2 equals ln of 18. The next thing we want to do is we would like to divide by ln of 2. We have ln of 18 over the ln of 2, and don't fall for it. You can't divide those. ln of 18 and divided by ln of 2. The 18 and the 2, they do not divide. Okay. Now what we're going to do is we're going to subtract ln of 18 over 2, ln of 18 over ln of 2, and add x to both sides to get our answer. Okay, so these just swap to locations. Okay. All right, well, let's try another one. Okay, so we have 16 to the x plus 4 to the 2x minus 1 is equal to 144. So this one's going to be a little bit trickier because we got two exponentials, and some way I'm going to want to factor them. So I'm going to look at the bases. 1 is 16 and 1 is 4. So the common base there is 4. Okay, so we have 4, and you have 4 squared to the x. Well, when I have exponent to an exponent, I'm going to multiply. So 4 to the 2x. Plus 4 to the 2x minus 1 equals 144. What I can do is I have a greatest common factor of 4 to the 2x, okay? And what we're going to do is we're going to use the fact that 4 to the 2x times 4 to the minus x, when you multiply like bases, you keep the base and you add your exponents. So that's what we're going to do here. Now, see how I have a common factor? That's just like having x plus x times 4 to the negative x. Oops, negative 1, excuse me. So we can factor out an x, and what we're left is 1 plus 4 to the negative 1. Okay, so there's the x. That's the same thing as what's the 4 to the 2x is going to be when we do the factoring. So that's what we're going to do here. So greatest common factor is 4 to the 2x. That's going to equal 144. So factor that 4 to the 2x out, and what we have left is 1 plus 4 to the negative 1, which is the same thing as 1/4. That's equal to 144. Okay. Now to isolate the 4 to the 2x, we're going to divide by 1 plus 1/4. Now 1 plus 1/4 is 1.25. So how I got this number is I did 144 divided by 1.25. 1.25 is just this number here. Okay. Now we have the exponential isolated. So what we can do from here is we can take the natural log to undo the exponent. So then we'll take the natural log of both sides, and the x will come down. And the last thing we need to do is we just need to divide both sides by 2 ln of 4. Okay. So we're going to look at one more. And let's say we have pi to the 1 minus x equals 2 to the x minus 1. So we don't have the same base, so we're just going to take the natural log of both sides. And then we're going to use the power rule, and the power rule is going to bring down both of those exponents. So bringing down both those exponents, now I have a problem here. I want to solve for x, but it's on both sides. So what I need to do is I need to distribute and then get all the terms with x on one side of the equation. So I'm going to go ahead and distribute. So you have ln of pi minus x ln of pi, and that's going to be equal to x ln of 2 minus ln of 2. Now we're going to move the terms with x over onto the right hand side, and it doesn't matter, you can do it to the left hand side. So we're going to add x ln of pi to both sides, and we're going to add ln of 2 to both sides. So that's going to give us all the non-x terms on one side of the equation here. So we have ln of pi plus the ln of 2. And on the right hand side, everybody has an x. We're going to factor out an x ln of 2 plus, or doesn't matter, ln of pi plus ln of 2. So the order doesn't matter. And then what we're going to do is we're going to divide both sides by ln of pi plus ln of 2. Well, that's what you got to go over here. So when you divide them, you're just going to get 1. Okay. So these are a little bit more advanced examples of solving some exponential functions, equations, where the bases aren't the same. So they'll take a little bit of practice, but just got to work through them.